Welcome to class 2. Let's take a look at some of the stuff that's going to be happening. Not all of that's going to happen in the first video. We're going to try to get done with a warm-up. We're going to do quite a bit of review today compared to usually, but it's important that we get some of that stuff down. And then we're going to try to do a little experiment with some triangles. We'll see how far I get into this first video. Well, let's start with a warm-up. Please pause my video and do this before, or try to do this before we get started. Alright, if you are unpaused now, then we're going to have, here's our world. And our world has a rope wrapped tightly around the earth, around the equator. Now we're going to increase the length of that rope so that it stands about 1 foot off the ground all the way around the world, on top of the water, on top of the wherever mountains, whatever it is. How much longer would that rope be? Well, we know that pi times diameter would give us our circumference. And we know that if we added enough rope to add 1 foot to each side of it, so it's 1 foot further on this side and 1 foot further on that side, then we know that the second rope, that's much longer, is going to be pi times whatever the diameter plus 2 feet is. And to find out how much longer that is, we're going to subtract off pi times diameter, which the original was. And so if I distribute, I get pi times diameter plus 2 pi minus pi times diameter. And I'm with 2 pi feet longer. So whatever 2 pi feet is, I'm going to go with 6.28 feet longer. So it isn't that much longer rope to make it a foot above the ground everywhere. Alright, so let's talk a little bit about some of these and try to see if we recognize them. So vertical angles are anytime two lines cross, you get two sets of vertical angles, those two and those two, and we know that they will be equal to each other. We also know that the triangle sum theorem said that the three angles of a triangle always add up to 180. Angles formed by parallel lines and a transversal. Let's see if we can do a little bit of labeling here. 1, 2, 3, 4, 5, 6, 7, 8. We know that corresponding angles would be, an example of that would be 1 and 5. And we also know that 2 and 6, 3 and 7, and 4 and 8 also work for that. We have alternate interior angles. An example of that might be 3 and 6. 4 and 5 also work. We have alternate exterior angles, so if we go with 1 and 8 or 2 and 7 would work for that. And then we have same side interior. That might be the 3 and 5, but they're not congruent to each other. They are supplementary. Okay. Now those are the original. Notice that I put in here, we have to talk about the converses of those. So the original statement would be, if you have parallel lines, then any of those four would be congruent. The converse would be, if any of those four are congruent, then the lines are parallel. Okay? So we're going to be using those converses, and you have to say converses, to prove parallel today. The remote interior angles, the sum of the remote interior angles, and the sum of all the exterior So the sum of the remote interior angles and the sum of all exterior angles of a triangle, let's see if we can. So if this angle here, we'll call it angle 3, is going to be equal to angle 1 and angle 2. Okay? So angle 1 and angle 2 add up to angle 3. So the exterior angle is equal to the sum of the two non-adjacent interior angles. Okay? Congruence theorems. Experimenting with congruence theorems. Let's see if I can get my... Alright, so now that we have the camera on my cute little triangles here, we're going to talk about what happens if I have three sides that are the same. I'm going to say A, B, C, and D, E, F. So we know that if A, B, and D, E are the same, then we have one pair of sides that is congruent. If we have the other two sides are congruent to each other, we can say, because there's only so many ways you can prove triangles congruent, and if all three sides are the same, then there's no other way you can draw that triangle. You know, you can flip this, rotate it, whatever you need to do, but it's still congruent because this side and this side are still the same, this side and this side are still the same, that side and that side are still the same. So if you have all three sides the same, then they have to be congruent triangles. So I'm going to abbreviate that side, side, side. Does it matter what shape they are? You know, somebody might say, oh gosh, if it's a different shape, if I pull in my other triangles here, and I have them like that, do I still have sides that are the same length, this side and this side, that side and that side, that side and that side? Hopefully it does not matter. Now, if I take my original triangles and play with them a little bit here, and I say, hey, I have this side, DE, this side here and this side here are the same. This side here and this side here are the same, the EF and the BC. And angle E is congruent to angle B. So I have an angle between the two sides. Is there any other distance that this third side could be if the same opening and these two sides are the same length and the opening is the same? Is there any other distance that there could be for that third side? No. Now, if I pick two other sides instead of these two, if I did this side box and this side box instead of this one, well, cross that one out. If I have the dot in the box and C is congruent to F, could this opening be a different size? No. So we know that if we have two sides and the angle between them, that they have to be congruent. All right. So then, let's talk about if I have two angles and the side between them. So let's say if I have this angle D and A are the same, and F and C are the same angles, and the side between them, box in this case, is the same as box. Could this angle over here or these sides be any different length? No, because we have two angles and the side between them, there's no other way to draw it. You know, even if it's upside down and flipped, you're still going to have the same triangles. All right, we're going to stop there, and we're back on this. And I wanted to save the last one. If I have two triangles with the same angle, side. So if I drew two, let's see if I can do this. This angle is the same as this angle, and this angle is the same as that angle. Could I draw, and this side is the same length. If I tried to shorten this side in here, would this be as long? No. If I tried to lengthen this, made it longer, then this side would be longer too. So because this side has to be that same length and these two angles have to be the same, there's no other way. So let's look at the 4 ways that we have for proving congruence. Oops, I guess I don't have that slide here. So the options that I have are side, side, side congruence, side, angle, side congruence, and the 2 with the angles, angle, angle, side, and angle, side, angle. So anytime you have 2 of the 3 angles and 1 side, you have congruence. Alright, so enough of the review. Why don't I pause there and make a new video, because we only have 4 minutes left and I can start on the new stuff with a new video.